Hello. This video should introduce you to the force unit project, the end of unit assessment or the end of unit project for forces. This should take, I think, just if we spend an hour a day, this should take us 2 days. Thursday, Friday should take care of it. The goal: find an image, take a photo shot of or a screenshot of an action shot that has 4 different objects that we will study. It can have many more objects than 4, but we need 4 that meet some specific criteria. It can be a picture or something you find online. It can be a picture you take. It can be a picture you've already taken. We need an electronic version of it, and we're going to analyze forces on those objects using things that we've already done, using some similar methods. So in that single image that you take, there must be 4 objects. There can be more than 4, but we're going to analyze 4. One of the objects must be falling or in the air from being thrown or hit or something like that. So like a sports image, if there's a certain sport you like, you can take a shot or a screenshot or a picture of something like that. That works really well. If you're not into sports, outdoor nature scenes, things like that are helpful. This thing that's falling should not be propelled, so it shouldn't be like a plane or a helicopter or even a bird or something like that. That doesn't quite work for the falling. It could work for the objects 2, 3, 4, but not for object 1. So it could be anything, but not anything that's falling, not just anything that's in the air. And it needs to have really only one force acting on it. Object 2 must have 2 forces acting on it. Object 3 should have 3 or 4 forces acting on it. Object 4 also 3 or 4 forces acting on it. Of those 4 objects, at least one has to be changing velocity. That could be speeding up or slowing down. We have the word accelerating here, or acceleration. We often think of that as meaning speed up, but it's really just any change in velocity. So something is accelerating if it's speeding up, something is accelerating if it's slowing down, something is accelerating if it's changing direction. So one of the objects has to be changing velocity. One of the objects must be in equilibrium. Remember, equilibrium is the fancy $2 word for saying that the total force adds to 0 and the velocity is constant. So this object that's in equilibrium could have a constant velocity of 4 meters per second. It could be 25 miles an hour. It could be a velocity that's constantly 0. As long as that velocity is not changing, that's the important thing. Then of these 4 objects, we need to know the mass or be able to find or figure out the mass for each of those objects. Remember, mass is in kilograms, not pounds, not newtons. So if you have a person in the picture and you know that person, you can ask them what they weigh if they're somebody you know like that. Excuse me. And once you know the weight of that person, then you can ask Google to convert weight in pounds to a mass in kilograms. Mass is how much stuff is there. It doesn't include the effective gravity. We need to know mass. So if it's a person that you know personally, you can ask them, or if it's a person that's famous or Googleable, you could Google, hey, what's the weight? What does so-and-so weigh? If it's a sports person, that's surely available. And then you can have Google convert that from pounds to kilograms, mass in kilograms. If it's just some random person that you just ended up happening to be in an image that you like, you can say, what's the average? You can ask Google what the average person weighs, and then you can ask Google to convert that weight in pounds to a mass in kilograms. It needs to be, the objects need to be something that we can find the mass of. You can, if it's an object or a bird or an animal, we can usually find those masses or find the average mass for those things online. But remember, they need to be in kilograms. Note that there is always a gravitational force acting on things due to the Earth pulling these things down. There's a gravitational force of the Earth pulling down on objects. That's going to be true for everything here. The thing that somebody might bring up as an exception might be talking about things in space. There are still gravitational forces there. They involve a different type of calculation. And since we haven't really done that, I suggest you avoid images of things that are in space. I think that might make things a little bit too difficult because we would have to introduce new calculation types. When it comes to air resistance, you can choose. You can choose if you're going to include air resistance, if it's significant, or you can say, I think air resistance or air friction is small enough to ignore. If somebody's playing baseball and they're throwing a curveball, they're using air resistance or air friction to throw that curveball. So then in that case, you would be wise to say, hey, air resistance is significant, and that's a force I'm going to include. If it's something else that's a bit more subtle, subtle is maybe not the best word, but if it's something where air resistance is not a huge factor, you're think of the sort of daily thing where you maybe you toss the remote control to a friend or your brother or sister or sibling or parent. For that, you're not really whip chucking that remote control over. It's probably just a flow. Yeah. And for those things, if they're moving slower, then air resistance is probably small enough to ignore. It's reasonable. You're able to make those choices while you're doing things for these calculations. You can choose to say, I think in this case, air resistance is significant, and I'm going to include that as one of my forces. Or you can choose to say, I think air resistance is probably small enough to ignore, and I'm going to ignore it. That's a reasonable and legitimate choice. The process that we go through, you need to find an image that you like. So if you have an image that immediately comes to mind, just make sure that you have objects that meet these requirements. If you don't have an image that you like, but you have a thing that kind of is your deal, if you're a football fan, dare I say, you're still a Vikings fan after the way things have started, you could go to an image of a Vikings football game, and you could include a snapshot of that. If you're a Green Bay Packer fan, then you should still choose something else because the Green Bay Packers are never an acceptable choice. I guess you could do the Green Bay Packers, but we need to talk about your life choices. But you can choose your favorite team, take an image of that, a snapshot of that, and you can analyze the objects here that are in that image. If you're not a big sports person, then nature shots work really well because there's often something going on there that has multiple forces or multiple objects included that you could include. It might be possible to take a snapshot or a screenshot of a video game that you play. We just need to make sure that the images that we take are school appropriate. So, appropriate in your house and your family. With your family is one thing, but like first person shooter games, no, that's not going to work. If the video game that you like doesn't have that sort of violence, or that is not a part of the image that you take, that's something you could use. Remember, you still need to have those four objects. If it's something that involves magic or mystical things, we would have to be careful because I think some of those, it's really tough to make up a mystical force to allow some of those things to happen. So video games, a screenshot of a video game would probably be okay, but you would need to make sure that you don't have, first make sure that the image is school appropriate. Then we need to make sure that the stuff that the characters are doing is something that is realistic enough to include some sort of physics analysis. We don't want to be making up, the mystical force of the thing doing the stuff so he can levitate and shoot lasers out of his fingertips. Yeah. That would end up being not a legitimate not a good choice, but other sorts of video game analysis things would work. But like I said, no first person shooter, no Grand Theft Auto stuff. Make a copy of the image if it's especially if this is like a family portrait or family picture of some sort. You want to make sure that you're not digitally drawing on the only copy that your folks have. Then in that image, you're going to have to identify the objects by adding arrows or circles to highlight those objects, those images, the things in there that you're studying. So we'll switch to a sample right now. So for this one, there's a bird that has just caught a little fish and they're hitting the water. So the sample here, the bird would be object 1. It looks like the little fish is object 2. This droplet of water is object 3. And the puddle, pond, lake, stream is object 4. So we have those 4 objects that are selected. Here the author chose to draw arrows to those. Instead of drawing arrows, if you want to, you can circle those objects, whatever works for you. But you notice that we have these things specifically chosen or selected and highlighted. So now we have those objects and we can go through and the person can show what they're doing on those things. Then there are slides that include object 1, object 2, object 3, object 4. You can either write these things out, write the questions or your solutions to those questions out on paper and take a picture and upload it, or you can go through in that slide and do all of the work digitally with your Chromebook or computer. Either way is fine. If you take a picture, then you need to upload those things. And the things that we're doing are going to be a system schema, a free body diagram. That's that force diagram we did in the physics classroom where there was the box and then there were arrows going off of the object to show what the forces are. And then some justifications and some calculations. So we're going to do, you can find the mass of things by doing a search and converting those things to kilograms, mass in kilograms. We're going to add the forces and compare them compare the total force to 0. So we can say something like the total force is 0 newtons or the total force is not 0 newtons. And we'll use labels from the free body diagrams for what some of those forces are. We can calculate the gravitational force that the Earth exerts on these objects, the weight. And that, remember, weight, and this is again in a physics classroom assignment, the weight of an object is its mass in kilograms times g. And g on Earth, on the planets, on different planets and on the moon, it's different. But on Earth, g is 9.8 newtons per kilogram. So if you know the mass in kilograms times g is the weight or is the force due to gravity that the Earth exerts on that object. Ballparkish stuff, an apple is about 1 newton. A quarter pound is about 1 newton. And then we also need to justify or declare if the object has no motion, if they're sitting at 0 velocity, 0 meters per second, if it has a constant velocity, or if it's accelerating, if there's a change in velocity. And we'll put those abbreviations on that sheet, on the slides. So here's an example using the bird image, the wildlife image. So the force is on the water. So our system schema, there's a text box where we typed in water drop, and that water drop has a gravitational interaction, the dotted arrow, between those 2 objects. There's the Earth, there's the water droplet, and the water droplet is the thing we're studying. There we go. The free body diagram or the force diagram, this black dot represents the water. If you would rather draw just like a little box, you could do that as well, but a dot is the common method. So we could say this dot represents the drop of water, and the only force acting on it is the force that the Earth exerts on the drop. So the drop is the thing that's getting the force. The Earth is this thing that's doing the pushing or pulling. Estimated mass, and it says estimated, right? So we obviously didn't take that droplet and put it on a scale. The sum of, or the total horizontal forces side to side, well, the only interaction is gravity, so that's an uppy downy. There's nothing acting lefty righty, so the sum of all forces in the x direction are 0 newtons. There's no force acting left or right. The sum of all forces vertically or up and down, the sum of all forces in the y direction equals, well, the only force we have there is the gravitational force, this single arrow going down. And that is the force that the Earth exerts on the drop. That is not 0 newtons. And then we can say the gravitational force, actually we'd be switching that A to a G, is 0.001 kilograms times 9.8, and we've been using newtons per kilogram. And so 0.001 kilograms times 9.8 newtons per kilograms gives us that. And then is the object, is it not moving? Is there zero motion? Does it have a constant velocity, or is it accelerating? Well, this droplet as it falls should be changing velocity. So that change in velocity means it's accelerating. So you can go through and do that like this and put things in these spaces that are provided. Or if you would rather do things writing out pencil paper, here's an example of these things drawn out pencil paper and then the image inserted into this page. That's perfectly fine. And as we continue on, these sorts of things are possible here. And you'll notice on this slide for the example version here, these things are all present in your default slideshow. So the slideshow that you're going to be using, these things are all present. So if you need more force arrows, you can add more force arrows. You can just do a copy, paste, right? And then you've got a bunch of those. If you need more of these, copy, paste, and you've got a bunch more of those. Any one of those, that sort of thing is perfectly fine. And the same thing goes for these. You can copy, paste, and just make as many as you need for what you're doing. And I think that is pretty close to where we're at. If you have any questions on this stuff, let me know. I suggest on there that today, on Thursday, you choose an image and you start to identify the objects in that image. All of those suggestions for what you do today are posted in Google Classroom. If you have questions, send me an email. On Friday, we'll have an all-class meeting at 1 o'clock again. And if you want to tune in and see what we have, see what questions you have, see what questions other people have, we'll start at 1 o'clock on Friday, and we'll take whatever time we need, and we'll go through and try to make sure things make sense. Good luck. Let me know if you have questions. Excuse me. Let me know if you have questions. And if we spend about an hour a day, Thursday, Friday, I think we should be in pretty good shape. Good luck, folks.